With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this problem, we have given to find the maximum magnifying power of a compound microscope having a 25 diopter lens as the objective and 5 diopter lens as the eyepiece, and the separation is 30 centimeter between the two lenses, and the least distance for clear vision is given as 25 centimeter. So for the maximum magnifying power, for maximum magnifying power of compound microscope we have m equals to v naught by u naught 1 plus d upon fe, where v naught is the image formed by the objective lens, v naught is the image distance of objective lens, u naught object distance of objective lens, and fe focal length of eyepiece. Now we have power of a objective lens as 25 diopter. So power of objective lens is 25 diopter. So power formula can be written as 100 upon f in centimeter equals to 25. Therefore focal length of objective equals to 4 centimeter. So focal length of objective lens is 4 centimeter. Similarly, we have power of eyepiece as 5 diopter. So 100 upon f of e, here we can write f of o, so equals to, in centimeter, equals to 5. So fe equals to 20 centimeter. Fe equals to 20 centimeter. Now we have calculated the value of fe. Now we have to calculate v naught and u naught. We have given that the separation between the lens is 30 centimeter. So here is a objective lens and here a eyepiece of compound microscope. The length, separation length, is given as 30 centimeter. Okay. Now we have to find v naught and u naught. V naught and u naught for objective lens. V naught and u naught for objective lens. So magnifying power is maximum. Magnifying power is maximum when image formed by eyepiece at d equals to 25 centimeter. That means least distance of clear vision. So for the eyepiece we have its focal length. Okay, so for the eyepiece, using the lens formula, 1 upon f equals to 1 upon v minus 1 upon u. So 1 upon u equals to 1 upon u equals to 1 upon v of e minus 1 upon f of e. Here v of e will be, since v of e will be this way, and this side as considered negative and this side as positive. So BE equals to minus 25 centimeter and FE equals to 20 centimeter. So 1 upon UE equals to 1 upon minus 25 minus 1 upon 20. So from here UE equals to minus 100 upon 9 centimeter. That means minus 11.11 centimeter. That is the consider this is UE. This is UE. Consider this is UE. So consider this is UE. And so if this is UE, then this will be equals to VO. So L can be written as VO plus UE. Therefore, VO can be easily found as L minus UE. So L is 30 centimeter and for distance UE is 11.11 centimeter. So this will be equals to 18.89 centimeter. Now we have to find UO. So again length formula for objective lens. So UO 1 upon F equals to 1 upon V minus 1 upon U. Therefore 1 upon UO equals to 1 upon VO minus 1 upon FO, and 1 upon VO is 18.89 minus 1 upon FO. FO is 4 centimeter. So from here UO can be written as minus 5.07 centimeter. After calculation we will get this value. Now we can find the value of M easily. So M will be VO upon UO 1 plus D upon FE. So VO is 18.89 upon UO is minus 5.07, 1 plus 25 upon FE. FE is 20 centimeter. So it is 20 centimeter. So from here the magnification will be equals to minus 8.376. So this is the magnifying power and this is the solution of this problem. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.